Okay, Unit 3 is on functions and inverses still. This is lesson 3.6 and not 3.7. And in 3.6, we're doing quadratics with the b term. So far, all the quadratics we've been doing haven't had the b term. They've just been ax squared plus c. Today we'll add in a b term. Remember, a quadratic is any function where the biggest power on the variable is a 2. If the biggest power is a 1, we call it linear. If there's no power at all, we call it constant. But here we're doing quadratics. Also remember, the inverse of a square is a square root. So when you're solving, we use inverses in SADMEP. Because we're dealing with quadratics and squares, that means we also just by nature have to talk about square roots. So let me explore square roots a little bit more. I'm going to solve this. I subtract the 5 from both sides. I get negative 2x squared equals negative 2. Divide both sides by negative 2, and I get x squared equals 1. Square root both sides, and x equals plus or minus 1. Do not forget the plus or minus. What we didn't see last time is something like this. Here, x squared equals negative 9. If I square root both sides, there isn't a number that I could plug in for x that would get me out a negative 9. Not a real number anyway. Like if I took negative 3 and squared it, I get out positive 9. If I take positive 3 and square it, I get out positive 9. There's no number I can plug in for x to get out a negative 9. So we say that this has no real solutions. The easiest way to write that is take this, backwards looking e thing and put a slash through it. This means x is not an element. X is not a member. And we can draw this fancy r with 2 lines. And this right here means x is not in the real numbers. You could just write no real solutions also. But trust me, writing this is faster, quicker, better. There's no real solution because some number squared can't equal negative 9. So if ever you have a square root that's equal to a negative, so here I'm going to have x squared equals negative 5/3. When I square root both sides, I'm just going to have to say x isn't a real number that I can use to solve this. If you do it in your calculator, if I do like the square root of negative 8 or something, my calculator is going to say error. Oh, actually, it says this I at the end. See that I right there? So really what I should do is change this to be set to real. And now when I do this, it says error, non-real answer. So if you see some error like that, that means you're trying to square root a negative number, and it's not going to work. Okay, another thing for us to look at. This is the first one we've had where there's a number inside here in the parenthesis. I'm still solving with SADMEP. There's no addition or subtraction outside the parenthesis for me to deal with. There is an addition or subtraction inside, but I've got to get to the parenthesis towards the end, so I don't deal with that yet. The first thing I'm going to do is divide everything by 4. That gives me x plus 3 squared equals 9. Now, the thing being squared is isolated. Since the thing being squared is isolated, I square root both sides. And this will give me x plus 3 equals plus or minus 3. Now I'm going to subtract a 3 from both sides. And that gives me x is equal to negative 3 plus or minus 3. So I have to do 2 steps here. I have to do negative 3 plus 3 to get 0, and do negative 3 minus 3 to get negative 6. So my 2 solutions are going to be negative 6 and 0. This is the first time we've had 2 solutions that weren't the same. Usually they've been plus or minus the same thing. But because there's this plus 3 inside here, we get two solutions that are different. Okay, let's do another one of those. Now here, you might look at this and think, hey, isn't this going to be equal to a negative? So when I square root, won't this be no solutions? Not yet. We first divide both sides by negative 2. And when we do that, we get x minus 1 squared equals positive 25. Which means this is going to have real solutions. I square root both sides to get rid of that square, and x minus 1 equals plus or minus 5. I add 1 to both sides, and x equals 1 plus or minus 5. So x is going to equal 1 plus 5, or x is going to equal 1 minus 5. So we know that x is going to be 6 or 4. Those are our two solutions. I can check by just plugging one of these in. If I plug in a 4 for x, I would do 4 minus 1 is 3. 3 squared is 9. 9 times negative 2 is negative 18. Wait, what? This is negative 4, not positive 4. I'm glad I checked. 1 minus 5 is negative 4. If I plug in negative 4, it's going to work. Negative 4 minus 1 is negative 5. Negative 5 squared is 25. 25 times negative 2 is negative 50. I didn't show it, but trust me, you plug it in, it works. Okay, last one. I don't have any multiplication or division this time. I'm going to get rid of this negative 6 first, so I add 6 to both sides. That gives me x plus 4 squared equals 6. Now with this one, when I square root both sides, I'm going to get that x plus 4 equals plus or minus whatever the square root of 6 is. Well, the square root of 6 isn't going to be a whole number. It's going to be some really messy decimal. So, I subtract this 4 from both sides, and the cleanest mathy way I can write this is negative 4 plus or minus root 6. And that's a really quick, clean, precise way to express this solution. However, there might be times where you need the decimal. So I'm going to calculate these two values. In my calculator, I'm going to do negative 4 plus the square root of 6. And I get negative 1.55. About equal to negative 1.55. And I'm going to do negative 4 minus the square root of 6. Negative 6.45. So the other way I could write my solutions are negative 6.45 and negative 1.55. So you can choose. Sometimes you need the decimal for like practical, sciencey reasons. Sometimes you just want to write down the precise answer. Notice how this can use an equal sign because it's actually equal to it. These have to be approximated because we're rounding. Okay, that's enough of our square rooting for today. We'll add one more layer in the future. Maybe. Yeah, definitely. Let's talk about graphing now. We're going to graph with a bx term. By that I mean, in the past, well, we've talked about how quadratics can be x squared plus bx plus c. But in the past, we've been graphing quadratics that don't have a b term. Like here, the a value is 1 and the c value is negative 3. But the b term was skipped over. b would be 0. And that graphs, like this. Now we're going to graph by throwing in this b term. So in this equation, the a value is 1, the b value is 4, and the c value is negative 3. The key to graphing parabolas is what's called the axis of symmetry. The axis of symmetry is a line, a vertical line that cuts the graph in half. With most of our graphs so far, all of our graphs so far, the line of symmetry has been this y-axis right here. But we're going to start moving the graph around. The vertex is going to be in different spots, and that changes where this line of symmetry is. See, when you have a b term, the b term changes where your vertex is. It's no longer going to be on the y-axis. So here's how you can find the axis of symmetry, and we call it the AOS for short. To find the AOS, it's the equation x equals negative b divided by 2a. So this equation here lets us find the line of symmetry that cuts the graph in half. So negative b is negative 4, and 2 times a would be 2 times 1. So this becomes negative 4 divided by 2, which is negative 2. So the line of symmetry for this new graph I'm making is going to be here. This is my line of symmetry, x equals negative 2. Now that's really important because that is going to be where the vertex is. The vertex is going to be somewhere on that line. See, the real key to the axis of symmetry, what's really helpful about this, is you can take that point and put it in the middle of your table. Then after you've done that, count up a little bit and count down a little bit, and these are going to be the 5 points I'm going to graph. It used to be we would always plug 0 into the middle of our table. But now we're going to plug in whatever that AOS is, whatever negative b over 2a is. So you take negative b over 2a and you put it in the middle of your table, and that's the best and most efficient way to graph these. So I'm just going to calculate f of negative 2. I'm going to plug negative 2 into this function here, into these two x's. It's going to become negative 2 squared plus 4 times negative 2 minus 3. Well, negative 2 squared is 4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4. And negative 4 minus 3 is negative 7. So the vertex is at negative 2, negative 7. It's going to be right about here. I think this is the first time we've had two x's to plug into. Okay, I'm plugging negative 2 in for x. It goes into this x here and this x here. Okay, I'll plug in something else. Let's do f of negative 1. That's going to become negative 1 squared plus 4 times negative 1 minus 3. Negative 1 squared is 1. 1 minus 4 is negative 3. And negative 3 minus 3 is not 0, it's negative 6. There's going to be a point here at negative 1, negative 6. But that also means, because of the symmetry, there's going to be a point here. Finally, let's do f of 0. F of 0 is nice and easy, because 0 squared is 0, and 4 times 0 is 0. So this becomes 0 plus 0 minus 3, which is just negative 3. There's going to be a point here and a point here. So this graph goes like this. Curve that a little better. It has a y-intercept at 0, negative 3. The y-intercept is always the c term. This is your y-intercept. And it's got a couple of roots. There's a root here, and there's a root here. We'll talk about how to find the values of those roots in our next video, but not this one. So, we've got a vertex, we've got a y-intercept, we've got two roots, we have our AOS, we've got 5 points. It's a very good looking parabola. Remember, calculate your AOS, which is negative b over 2a, take that value, whatever that is, and put it in the middle of your table. Then from there, count up a few and count down a few. Let's do one more. Negative 2x squared minus 4x plus 3. Take a second and identify a, b, and c in this. The a term is negative 2. The b term is negative 4. The c term is 3. So the first thing I want to find is the line of symmetry, which is negative b over 2a, which is going to be negative 4 over 2 times negative 2. So notice how this has a negative term in it, but then b is also negative. So negative 4 is just 4. And 4 divided by negative 4 is negative 1. So I'm going to put a negative 1 in the middle of my table. My line of symmetry is the line x equals negative 1. So negative 1 goes in the middle of the table. I'm going to go up a few points and down a few points and plug in these 5 numbers. Although I really just plug in 3, because if I find this one, I get this one. And if I find this one, I get this one. So let's do negative 1 first. F of negative 1 is going to be negative 2 times negative 1 squared minus 4 times negative 1 plus 3. So I just write it out first. And do the squaring first. Negative 1 squared is positive 1. And negative 4 times negative 1 is positive 3. Negative 2 times 1 is negative 2. Negative 2 plus 4 plus 3 is 5. If you plug in a negative 1, you get out 5. So here's my line of symmetry. And there's the point negative 1, 5. That is my vertex. The point negative 1, 5. Plugging in 0 is pretty simple. If we plug in 0, we get out 3. So I have a point here and a point here. It's symmetric. And plugging in 1 is also pretty straightforward. It's negative 2 times 1 squared minus 4 times 1 plus 3. Do the squaring first. 1 squared is just 1. This is negative 2 minus 4 plus 3, which is negative 6 plus 3, which is negative 3. There's going to be negative 3's on top and bottom. So I have 1. Hi, Christmas trees. I have the point 1, negative 3, and I have the point negative 3, negative 3. I have this parabola. I have a y-intercept at 0, 3. I have roots here and here. I'm not sure what those points are. So this is me graphing the parabola f of x equals negative 2x squared minus 4x plus 3. Beautiful stuff. Nice work. I should also label the AOS. The AOS is the line x equals negative 1. Okay. A square root is equal to a negative number. If a square root is equal to a negative number, then the root has no real solutions. If I try to find what squared gets me negative 16, that's going to give me x equals the square root of negative 16, and that has no solutions. So x is not in the real solution set. So we can write x is not in this fancy R. If a quadratic has a parenthesis, we isolate it and then continue solving following SATMAP. There'll be two solutions, and you have to deal with both of those. If a quadratic has a b term, the vertex is no longer on the y-axis. Find the AOS with the formula x equals negative b over 2a. Then take that value, negative b over 2a, and put it in the middle of a table. Pick a few points above and below, and graph. It should be symmetric if done correctly. Awesome, we're done.